So what do we mean when we talk about composition, about composing things? My name is Eric Normand, and these are my thoughts on functional programming. Just one little note behind me, what you're seeing is Portland, Oregon. I'm in town for a conference. Just thought you might want to know. So, what is composition? Someone was asking me today, because I use the term without defining it. So I've been thinking about how to explain it, explain what I mean. And I think it means different things depending on the kind of thing you're composing. So let's start with the easy ones. When you compose actions, there's really just two ways, I think, to compose two actions. And composition is really a binary operation. You take two things and you put them together. So when we have two actions and we put them together, there's two ways to do it. One is you can run them in order, in a sequence. So you do one action and then the other action. And the other thing is you could run them in parallel. So you can run them both at the same time. And when you run them in sequence, you can make it so that the result of one action, so let's say reading from the file system, is passed to the next action as an argument. And that lets you, do a different thing depending on what the result of the first one was. Now, when you run them in parallel, one thing you could do is get both of the answers back in something like a tuple, right? If there are results that you need to do. But otherwise, you could just run them in parallel and compose them that way. So you can see you can compose up things in sequence and then have two things that you've composed up run in parallel. So you have two different timelines running with different sequences going. And so you build it up. You compose it up two things at a time. And of course, we talked about how two actions, when you compose them, give you a new action. And so if you compose up only actions, you'll only have actions. Now, what about calculations? There's a thing in math called function composition, and it's similar, except I think that it's more general than the one thing called function composition. And that's, function composition is, you run a function, and the only reason to run a function is to get its return value, right? Is to get the result of that calculation. So you run a calculation, you get the result, and then you pass that result to another calculation as one of the arguments. And then you get another result. So you're taking two calculations and you're running one first and then running the next one on the result of that. So it's binary. It takes two calculations and returns a new calculation. And that calculation runs the first one, gets the output of it, and passes it to the second one as one of its arguments. The function composition that mathematicians talk about is one where the second function has one argument and that's the thing that the output goes to. But I really think that that's a very limited view. You could have other arguments in there. Okay, so that's composing calculations. Now, what about data? Data is actually the more complex here, because in data, you can compose in so many different ways. It really depends on the data structure. Whatever structure you're using tells you how you can compose. So if you're using a list, you can compose a new thing onto that list using like append, or maybe you are adding to the front. You know, you could be adding to the front and you could be adding to the end. So you're composing in that way. You start with an empty one and you compose on a new thing, you compose on a new thing. Now if you're using something like a set, you're composing without order, but you have this idempotency thing, that your compose operation is idempotent, meaning if you add the same thing twice, it doesn't add it the second time. It only remembers one time. Or if you have something like a hash map or an associative array or whatever you want to call that, the semantics are that you need a key value pair. So you compose using that. So data, when you compose data, it's really about the same thing. It's a binary operation. You're taking two pieces of data and you're putting them together in a new piece of data. How that works depends on the two pieces of data and their semantics. So that's why it's more complex. It's more complicated. Because data represents relationships, and there are lots of different relationships that you need to represent. So there's different shapes of data with different properties for those shapes. All right, so I think that explains it pretty well. It's a pretty general concept of composing things together. But I should explain it, obviously, because I talk about it a lot. If you have any questions, you want to get in touch, I loved getting this question, so please feel free to get in touch with me. On Twitter, I'm at Eric Normand with a D, and my email is eric@lispcast.com. I love getting emails and responding to them, so please get in touch with me there. As always, these were my thoughts on functional programming. Please subscribe and like it, and I'll see you later. Bye.